Hello everyone, my name is Yilin Jiang and I'm a PhD student in OU. Today I'm going to talk about the design of a home energy management system, also you can call it home EMS. Before I start, I would like to thank you for my co-advisors, Dr. Li Song, Dr. Frank Mistry, and Dr. Janae Allen. So let's start at the overview of home EMS. The home EMS want to minimize the cost of electricity, meanwhile maintain the satisfactory comfort for the homeowner. Also, it's very meaningful to reduce the peak load contribution for them. So to achieve these goals, we have built a nonlinear mixed integer programming model. However, in the model we have multi-objectives. To address these multi-objectives, we have used the compromise decision support technique. To use this CDSP, we can explore the solutions based on homeowners' preferences. As we used the model in our test problems, we found that the home EMS achieved our goal. In the future, instead of implement the model in a single house, we want to implement in multiple houses and even the community. So why home EMS is so important? The picture over here is a US annual electricity sale. So the residential building is a blue curve. Actually, it consumes a lot of energy. The industrial building, the yellow curve over here, is actually moved overseas after 2000. And because they have more motivation to save more energy, they already have the mature energy saving system. For commercial building, they have less control flexibility because they have own purpose to do their activities. So it's time to pay more attention on residential building. The picture over here is the Texas power outage. I think a lot of people experience that this winter. The customer have to line up to buy the propane. So under some extreme condition, homeowner might experience some power outage, or they will receive a higher electricity bill, or both. So recent years, the electricity supplier just introduced a time of use rate to the residential buildings. The electricity rate is not always constant. The suppliers introduce time of use to the residential buildings. For example, during the summer, you can see this is a time of use. Your electricity bill could be very low from midnight to 6 a.m. But from 4 p.m. to 9 p.m., for example, it could be doubled. By increasing rates during off-peak hours, the suppliers want to regulate the energy usage from their customers. However, if you want to put all your appliances into off-peak hours, you might cause some problems with high peak load. The high peak load will bring a lot of stress to the grid. Also, the high peak load during the off-peak hours is not desirable. It can be discomfort, it can have lots of carbon dioxide. In our home energy management system, we want to use the Raspberry Pi to connect all the appliances and use our model to schedule all those appliances. The final cost and peak load will be returned to the user. User can also have their own preferences to the system. The thing is, we also need to deal with the coupling effect between those appliances. So in home EMS, the appliances are divided in two parts, thermal appliances and non-thermal appliances. So thermal appliances is like a water heater. They have their own heat transfer process. Like in the hot water tank here, the water will be withdrawn and the cold water will come in. That's why they have the three energy flow. The first one is the thermal leakage, depends on the water tank properties. And second one is the incoming electricity power. Third one is the thermal loss due to the incoming cold water. The ODE is listed here. Each box represents the different heat transfer part. So in our home EMS, we will always want to maintain the water heater into a certain level to maintain the satisfactory comfort. For example, the temperature of water heater should be maintained 40 degrees to 60 degrees. However, the non-thermal appliances like a clothes washer might have some coupling effect with the water heater, because the water heater, the third one, will have some water withdrawal term, which is W here. The water withdrawal can come from the clothes washer. That's why we need to modify the third terms into this way. The X means the clothes washer on-off signal. WJ is a clothes washer water withdrawal. In this new equation, the clothes washer and water heater coupling together. Here are the part of important constraints in our model. This is the objective function we have. Like I said before, we care about the cost. We also care about the peak load. So we have two objectives. In summary, we want to minimize these two objectives and subject it to some constraints. And here is the boundary of the decision variables. So the problem is we have two objectives. Usually when people dealing with two objectives, they usually connect them using some linear combination and transfer them into one objective so that they can do the optimization problem. We also want to do that, but the thing is, the unit of the first objective function, which is cost, the unit is dollar. The second objective function, the unit is watts. If we're just using some linear combination of two, it does not make sense. That's why we have to use the compromise decision support problem. So the CDSP is also dealing with multiple goals. Instead of connecting each objective using the weights, the CDSP transfers the objectives into goals. In each objective, it's divided by its target cost or target peak, and a new deviation variable introduced here. Deviation variable means over and under achievement from current value to the targets. And using this deviation variable, we can just minimize the deviation function, which is the linear combination of each deviation pairs. So the deviation variable also keep the weight here. So the homeowner can choose the weight based on their own perspective. We also implement our model into a tester problem. Here is the result. In this tester problem, we use the W1 equal W2 equal 0.5, which means we give the equal importance to the cost and to the peak load. And we can see the water heater here has a more frequently on-off, and it will heat the water inside it. And after that, the washer will run. Because the washer will run, it will withdraw some hot water from the tank. That's why the temperature will decrease in the tank. However, because the water heater preheats the water inside it, it will decrease, but it will still above the lower bound. And other appliances here, like the dishwasher and the dryer, they will also avoid the on-peak hours. On this side, this is the total power usage versus the time of use. We can conclude that the appliances avoid the on-peak hour, but it will not avoid the middle peak hour because appliances want to have less overlap operation to maintain the power in some certain level, so that it will not have a high peak load. And this table is more result when different weights can be chosen for the deviation function. If the homeowner values the peak load more, they might put more weights. They might have a higher W2, which means they put more weights on peak. Now you can see the peak is less, but you might have a higher utility bill. If you value the cost more, you might choose the higher W1. So the cost will be less, and the peak load, however, will be a little bit higher. So different weights can be chosen based on homeowners' preferences. The home EMS scheduled the appliance 24 hours ago and avoid on-peak hours for those appliances. Meanwhile, it manages the peak load and maintains some certain comfort for the homeowner. Homeowner can also have their own input to the systems. The model considers the coupling effect between those appliances. In the future, model can extend it by adding more appliances like HVAC and the shower model. From one house, we want to implement model to multiple houses and even in the community. If you have more questions, you can contact me. Here is my information. Thank you.